Hello, welcome back to the Arduino Starter Kit project. Today we are going to be doing project number 10, the Zoetrope. Now, you might not know what a Zoetrope is, but once you see them, I think you will remember. You've probably seen them in the real world or seen them as a kid. They're little spinning images that if you look through a hole as they spin, it looks like things are kind of being animated. I'm going to include a video of a fancy 3D Zoetrope to show you, and I'll show you a traditional one. I'll put some links and some videos just to kind of give you a feel of what you're making. If you look down here, this is kind of the end goal, right? We have this spinning wheel. Oh, sorry, I'll get that out of the way. A little bit crammed in the workspace today, right? And you're going to be able to turn it on and make it spin. You're also going to be able to change the direction of it and make it spin, right? So things like that. Now, that's not really all that useful from this angle. This is basically an extension of the motorized pinwheel with a little bit more. See, what you've done now is not only do you make it spin, but you can make it stop and start and control the speed. So you've basically made the last project, but much more complicated. Now, if you just look at it from this kind of perspective, as you look through the slots in the Zoetrope that you're going to make, as it spins, you will look down and you'll see an animation. Mine is of a little LED. Some of them are of flowers or plants, and the plants will grow and go up and down as you spin it, creating like an animation effect. If you spin it one way, things will move one way. If you spin it the other way, the reverse will happen, which is kind of cool. So that's kind of the project. Let's just look at, before we get into any of the other stuff, this is a tough one to build. So let's just look at the construction here to make it really clear, because I've had students do some pretty crazy things here. So let's see. You're going to basically take your pinwheel. I have glued this piece of wood permanently to this disc because you don't want this slipping. So I would highly suggest that. I've also glued this here. Now yours might already be glued. I used glue to keep this nice and tight. That gives me a top layer where I simply insert the top black cover first. I use the black cover and I put it into the 4 slots there. Then I take the smaller white paper and I roll it in there on the inside so that it makes a circle and you can kind of see the animation. It's like he's jumping, right? That's that. I've glued that. I have not glued anything else except the wood here and the paper to the disc. These can snap in and out and you can take them apart very easily if you ever want to go back, or if other people are using this kit in the future to do the digital pinwheel. So that's the construction. This is a little tricky. I would highly suggest gluing that in there. Otherwise you're going to have a lot of spinning, and every time you change directions, when you press that stop button or change directions, you're going to have loose parts spinning, and it's really not as fun. Another little hack before we get going is that, as we know, the potentiometers in the Arduino Starter Kit aren't that good. Not only are they kind of low quality, they don't really sit in the slots well, especially if you need to bend them a bit to make them kind of fit in a small area, right? If you look down here, you could see in this area, in the original illustration, they somehow magically expect the entire potentiometer to fit in 2 slots, when in reality the potentiometer takes up about 4 to 4.5 slots. So what I've done, as you can see here, is I have simply jumped. I put the potentiometer over the gap, so 2 pins are on this side, 1 is on that side. I wire those parts the same, but I jumped my wire from row 13 that goes to analog 0 here, and I've just moved it to the opposite, or the other half, because it actually has no interference with the other parts of the circuit. So I've simply put it over the bridge. You could actually put it all on one side, like the drawing, but it would be very difficult. So I would suggest doing what I've done here. Let's just take a closer look at that. You can pause this if you're having trouble. See what I've done here? I've put one side with the 2 pins there, and then I've got one on the other all by itself with the 1 pin on that side. It doesn't interfere with anything. It just makes it sit a lot cleaner. The other option, if you're feeling bored and you've got some soldering experience, is you could take a about 6 inches of wire and solder it to one of the tips of the potentiometer. Cut another piece, solder it to the other one, solder all three, so you have 3 wires sticking off your potentiometer. That'd be really useful, because then you could simply go here and use your wire potentiometer and just stick the wires in the right holes, like the diagram, and you'd have it kind of floating up in the air here on some long wires, and you could adjust it as you like. I would suggest that too if you're feeling ambitious. It's pretty nice, although when the wires are loose and you're trying to turn the potentiometer, sometimes they dangle, so whatever you like. I would probably start with this setup like I've done, slightly modified, and then depending on how that works for you, go to the soldering. You can see the code here. Let's take a look. That code is pretty intense. It is much more, right? We've got about 80 lines of code. And obviously, if you're in trouble, I can help you and send you that. This one's going to be a lot harder to verify. You're going to find a lot more errors, right? When you've got 80 lines of code, you really got to be studious. You got to be meticulous and take your time. I'm going to give you more time than usual on this project because the code is so long. The wiring is slightly complicated and it's finicky. Remember, when we're using potentiometers and switches, both of those parts in the starter kit are not the best quality, so there is problems with them sometimes. So you're going to meticulously go over that code. I'm going to give you some time. Let's take a look here for a second, because there's a couple things that we've got to learn. First biggest thing here is this H-bridge, or IC chip, as you can call it, right? An H-bridge or an IC chip. Potentiometer, nothing crazy there. 2 switches, nothing crazy there. Of course, we are powering the motor with 9 volts, but we are using 5 volts power from our computers to help run the Arduino circuit. It communicates to the IC chip, and the IC chip then activates power to make the Zoetrope spin. So it's kind of like 2 separate, it's like a left brain and a right brain almost, where this part's controlled by the computer, and then the motion is controlled with the power from the battery. And this is a communication device between the two, as is the IC chip that's actually, look at that, looks familiar, hey, on our Arduino. So let's just talk about what an IC chip is for a second. An IC chip is like a pre-wired circuit for you. You will see them in everything, and they're not that special. Look, I have, they're not expensive really, and there's very different kinds with different numbers of prongs. Look, we got some here that are much smaller IC chips, and they've all got numbers: 555, 74274, 74266. Every single number on there indicates a different kind of IC chip or H-bridge and what it's designed to do. So you pick the right H-bridge for your project. If you need something that controls direction of electricity, controls a motor, controls stopping or starting, it's like everything. What is wired in one of these chips, you could wire an entire Arduino and not even be able to do everything that this chip can. There is wires and circuits inside of it. There is solid state switches included in here most of the time, pre-built microscopically in here. So this is like doing a whole bunch of circuits for you. And depending on which pin you connect to, as you see, oh, let me put that in the right one. As you see, depending on which pin you connect to on the H-bridge, remember the little nub there, the little dent goes always towards the top in our projects. You can see that right there. Depending which pins you're using is what part of this chip you want to activate or circuit you want to use. So we use number 1, which controls the speed of the motor, and then we use pin, I believe, 4 and 5, which control the direction of the motor as well. And we are only using those parts of this IC chip. So and this one might control something different. This might make it do bursts. This might make it work on a timer or things like that. Every chip has different components that it can accomplish, and you can use certain parts of that chip at your leisure, as opposed to having to rewire an entire another circuit to do what this little thing pre-built can do for us, and we access the parts of it that we like. That is the biggest new tool in this project. This is something new for the Arduino Starter Kit. So I think I've kind of gotten through most of it. I've given you the warnings about how to build this, what you should glue, what you shouldn't, how to work the potentiometer, if it's trouble, what an IC chip is. The rest, I mean, let's just take a quick skim here. Let's look at the booklet. I'll help you out here for a sec. So you could see you're building a zoetrope that animates a plant. Well, some of yours might not be a plant anymore. They might be a little LED like that. As it spins, you will see things happen. Now, let's just talk for a second. Normally, instead of having these holes here where you look through as it animates, you would actually have a box further away with a hole in it that you would look through that and the zoetrope would spin from far away. But this is kind of like a modified version for us. So you're going to look through these slots. I've seen students take this paper in here, let's see there, right there, and put it through these slots. They wove it in and out. Nope, that's not how you do it. You just simply rest it inside like that. If you see here, right? The motorized pinwheel, you got it to spin one direction, but now you're going to take power and ground and flip the orientation. You could spin it the other direction. It's not practical that you're going to change the grounding and the orientation of the circuit every time. You're not going to rewire the circuit every time you want to change the direction to switch the positive and the grounding, right? So what you do instead is you use an IC chip that has that pre-wired into it, and you could switch between which pins on the chip you're using to change direction. H-bridges, known as IC chips or integrated circuits, are components that hold large circuits in tiny packages. These can help simplify complex circuits by placing them in an easy replaceable component. For example, the H-bridge you're using has a number of transistors built into it. The circuit inside the H-bridge you probably need in another. To make a circuit in an H-bridge, you would need a whole other breadboard. If you didn't have one of these chips, you could rewire it, which is pretty amazing. Moving on, we've got the wiring. Obviously take note of how that potentiometer is fictionally placed in the video that I'm going to give you with our guide from the Arduino site on YouTube. She actually wires it the modified way that I suggested as well. She didn't solder on, so you can use that to start with. Taking a look at that, please pay attention to that. This is the wiring instructions, and it also gives you a little bit of explanation of how things work. Take some time with that. And then we get into the coding, and we're adding a lot here. We're talking about direction. We're talking about on and off as well. And then there's how to wire, or how to make the zoetrope apparatus itself. Last but not least, I'm going to give you a little demonstration of how the zoetrope works. So let's hope this thing can be a little finicky. I'll give you a couple pointers on this too. Let's just talk about how to work this. You would simply put the motor on the bottom right here. You can see I've put that on there. Now I'm ready to go. I would love to hold it like this so you could see through and see the animation. You could kind of like manually do it. You can get the idea, right? You see things through the slots and it looks like they're kind of moving up and down. Don't worry. I will give you a video demonstration of some other ones in the real world and the fancy 3D ones as well. So here we go. We've got this. This is the on and off button, and this is the change direction button, and this is the speed, and I'm going to give you a tip on the speed as well because this can be a little finicky. So let's turn it on. Let's give it a little juice. All right. Oh, I can hear it wanting to move. There we go. Sorry. Just had it going. I think when I moved that one wire to show you, I think I might have loosened my connection. 1 second. Okay, troubleshooting. Make sure that's good. Make sure my connections are tight again. When I was pointing, I literally just had it going. Oh, there it was, I think. All right, let's see if I can do it without. Huh. There we go. Loose connection. So I've got it spinning one direction. I can stop it. I can start it. I can also switch the direction, which is kind of neat. You can see there. Oh, it's definitely loose at the chip. I just felt it move. Okay, good. All right, I know where the problem is. Here we go. Let's connect that. Yeah, I got some loose wires here because I've been moving it around. I built it in one room. So anyway, how this would work is you would put this on here. Oh, it's really taken off on me now. Sorry about that. All right, we'll turn it on. And if I want to change direction, so obviously you'd be looking through the side slots here to see the animation. Change direction, just push the button, it goes the other way. That's why we glue it all together so it doesn't fall apart. Now one tip, and you saw I just had a problem and I checked my wiring and I knew it worked and I rejiggered it and it all came together. Now this thing is spinning incredibly fast and that's not... it's spinning like you can't watch the Zoetrope like this. It's useless. One thing I have found to help with that problem, to make it so it's actually kind of cool so you can see what you're doing, you can make your own animations and put them in here too. But what I've noticed is I like to let it go full speed and then I use my dial and I literally bring it all the way down to stopping and then I just add a little juice back and I can get it kind of going at a fun speed where I can control it. So if you're having trouble, and that's mostly because so much energy is given at the start that the motor kind of gets away on itself and the momentum kind of makes it too powerful. So that's my tip to you. Oh, sorry, here we go. Let's look, right? So I go all the way up, full speed, and then I bring it all the way down and then give it a little bit of juice back, and you can see I can get a kind of controlled turn. I can actually control the speed. I find when I first power it up, the speed is out of hand. Watch, I'll switch directions. There we go. And then you'll see it starts getting crazy, so I just let it go full speed, and then I bring it back down. And then I add a little bit of juice. Now one thing here, I think you can actually see the animation if you look. Kind of. I can see it really well from where I am. One other thing that I'm going to warn you about, what was it? Oh, the potentiometer. Push down on it as you turn it. You can't just lightly turn the potentiometer. You got to kind of keep contact and push down to keep it going. Other than that, I'll include some videos. I'll include the Arduino video. I'm going to give you quite a few days to work on this because you've got a lot of coding. It's very meticulous. You've got some new parts. You've got some crafting work to do. And yes, I want you to do the craft aspect of this project. And if you want to make your own animation in there, by all means do it and submit it to me. But I hope you enjoyed this. And we're going to be moving on soon with an LED display to make a magic ball. You know, where you shake a magic ball and it gives you answers, except we're going to do a digital version of that. So you can kind of imagine what parts we might be using. What things were shake activated and turned activated. I think you could see some of the old parts that we're going to use to make a crystal ball in the next project. So I hope you've had fun. Thanks for bearing with me with some of that troubleshooting, and we will see you soon. Cheers.